so that others should also do here. Okay. Okay. So today's topic, classes and objects. It is a backbone kind of thing. The entire C++, remaining part of the C++ is based on class and object. Most of the concepts use the idea of class and object. So thorough understanding of class and object will help you to make out rest of the processes yourself, rest of the concepts yourself. So in this session, we'll try today. You have a lot of stuff to understand and discuss. We'll see one by one. Defining a class and the study of its access modifiers, creating an object and calling a member function, implicit object and accessing its states, explicit object and passing it to a member function, returning an object from class or member function, constructor, destructors, static and non-static members. So along with this theory concept, some programs are also there. We'll see how we make use of these concepts for programming. So let us first start with defining a class. Yesterday I told you to discuss is a collection of objects exhibiting similar characteristics. And so in is a template used for object creation. So what kind of that you have to specify in the class definition. Then that you can create objects from it. So what is the syntax of defining a class in C++? It is a syntax in C++. Here we have basically two sections, public and protected. Protected we'll discuss during inheritance in our subsequent sessions. Now for private and public are for us. So any private data or member function. What is a data member and member function? Data member basically it is a set of variables, data members. They are variables representing attributes of a class. For instance, if you take the class as account, bank account, the variables required like account number, balance, type, these are attributes of the class account and they will become data members of this class. And what are the member functions? Member functions, like you will be depositing, withdrawing, you want to see the balance, show balance, change the type, this sort of things. They are basically functions representing methods of a class. Yesterday we have seen a class has three unique properties, characteristics, unique class name, attributes, and methods. So here member functions represent methods of a class. Now we have two things here, private and public. What these are, we'll see. These are called access modifiers or scope specifiers. Access specifiers. They specify the access. So visibility. If anything is declared as a private, anything declared in the private section of a class, that is only visible to the class. It cannot be accessed from outside the class. Under no circumstances you are allowed to access the private data from outside the class, normally. If it is a public, yeah, it is possible. As the name tells, public, you can access from outside world. It is like a key. Anything declared in the public is a key. Through this key, you will open the private section. You will access the private section. First, you will enter in the public section. When you enter in the public section, you are in the class. So you will be accessing private. This protected is something like private only. It is used in inheritance. If private is not inheritable, so if you want the data to behave like a private and at the same time it should be inheritable, you will declare it as a protected. That more use we'll see in inheritance. So this is about scope and access modifiers. Now we are ready to write a program. We'll see one program. What is that? Define a class circle with data as radius, create one circle and compute its area. We'll now start applying object-oriented features. So it is not a C program wherein you start with a main, float, radius, area, enter, radius. It's not C. It's a object-oriented programming. So you must first define some class which represents a circle, and the variables of that circle class will represent objects. So class is basically a user-defined data type. It is a user-defined data type. You are defining the data type. So the class name acts as a data type, and then the variable name acts as object. See, let me show you here. Say the class name is account. Account is a class name. This will act as a data type. Now, when you want to declare a variable like int x, int is a data type, x is a variable. So x is an integer variable. Similarly, now account is a data type because you have defined account as a class. It is a user defined data type. Now, if I say account A1, now A1 is a variable of type account, but this variable is a special variable because it is of type class. So that variable is object now. A1 is object of type account. So same way now, if you want to define circle object, first you are supposed to define a class circle. You have defined a class circle. So this circle will act as a data type, and C1 is a variable. So the variable of class type is object. So this is how we create an object. Here A1 is object since the data type is user defined. C1 is object since the data type is user defined. You have defined it using class. X is not an object. X is a primitive type. It is an integer variable. Now we'll see one program based on this. He has asked us to define a circle, create one circle, and find its area. If I define this way, what's wrong with me? Is there any issue? I'm right. Just go through the code. This is a class circle. This is the class circle. This is a class circle. Then this is main. Now here I told you this circle. It's a class name. This acts as a data type, user-defined data type, and variable of user-defined data type is an object. This is how we create an object. The class circle is defined with its attributes. Circle has an attribute like radius, so we have declared it. I have not used the private section here. I am using only public section because I don't know private. Let us assume I don't know private. I will do like this. Then I'll create one object. Since public is accessible from outside world, so radius is accessible outside. Radius is in public section, so it is accessible outside. C1.radius, I have initialized it. So this is a initialization. Then the radius is initialized. Compute the area. Area will be 3.14. Again, that object's radius. C1's radius. So this is how it will give you. So when you run this program, you will get the output, say 3.14, 2.5. So area of circle is 19.625. So I'm perfectly okay with this program. So what do you think? What's problem? What's the problem with this one? Can you let me know? Come on. What is the problem here? You give your reply. Come on. What's wrong with my program? I can write this way. It is giving output. What's wrong with me? Come on, type and let me know. Can you hear me? Am I audible to you guys? Just go through the program. What's wrong with me? This is a very, what do you say, point, crucial point you are supposed to understand. The knot is here. If you open this knot, rest of the concepts will be clear to you automatically. Very easily you will have a flow of understanding. That's why I have taken this example. Come on this DOS screen, I'll not be able to read your messages. So I'll go to Windows. Yes, someone is saying it should be private. Why? I'm happy with public, man. What's wrong with me? We can use private instead of public. So most of you are saying that use private. If I don't use private, which feature of object-oriented programming I am violating? I am violating one of the features. Programming. You can make use of C. You define a structure like circle and do the same thing. Then why you are coming to C++? Oriented programming. Yeah, someone said encapsulation I am violating. Absolutely, you are right. So I am not encapsulating. I am keeping my data open to everyone. So radius is my data available, accessible to everyone. It should be private so that the outside world should not access it. Very good. Most of you are saying it should be, because we are violating the encapsulation concept. Now, what I do? You have said me to make it private. I'll make it private. What happens if I make it private? I'll make it private. I'll remove this public. Am I right now? Run it. Run it. You are accessing radius in 3 locations. So it is saying radius is not accessible. Radius of circle is not accessible because it is private. Very simple. This is how we confirm that the private data of a class is only visible to the class. It is visible inside the class. It cannot be accessed outside the class. Then if I want to initialize, what should I do? If I want to compute, what should I do? Are you getting my point? If you want to initialize, you must go to the class circle. If you want to compute area, you need to access radius. So you must visit the class circle. So to visit, you are in main now. You are in main. From main, you must enter into class circle. So what is the pretext of entering there, going there? You have to define some function in the class and call that function from main. You will automatically enter. So if you want to call that function in main, that function should be where? It should be in private or public? Should it be in private or public? See the screen now. Double radius. I have not said anything private here. By default, the data in C++, if you don't mention any access specifier, by default it is of type private. So you don't need to mention here like private. No need to mention. If you mention, it's okay. Even if you don't mention, by default, the data without any access modifier is treated as private. So radius is private now. You are supposed to initialize the radius. For this, I am defining init function here. Init. This init is defined in the public section. Init is defined in the public section. That's why it can be called from outside class. Yes, you need to use an object for it. C1.init, you will be using an object in it. The control will come over here. The control will come over here. 2.5 will be copied in X, and that 2.5 will be assigned to radius. This radius is of circle C1. C1 because init is invoked, init is called upon C1. That's why the value is of object C1. Now you initialized it, C1's radius you have initialized. Now compute C1's area. So again, find area, you are supposed to define one more member function in public section so that you can call from outside world. C1 dot find area. See again 3.14 radius into radius. So this radius is of which object? C1, the object which is used to call a member function. So now you got the idea. So return the value. The area is returned here to main and we print it. See, now you can see, run it and see, you will get an output here. So area of circle is 19.625. So why we need a member functions? You got an idea. Now, why we need member functions? We need member functions in order to access the private data of a class. If there are no member functions in the public section and you have something in the private, then that class is of no use. It is as good as you have lost the key. When you lost the key, you cannot open the room, you cannot open the lock because you have lost the key. So key is what? Member functions defined in the public section are keys, using which you will access the private data, you will process the private data and get the desired results. I guess you got my point. Did you find the significance of comparing these two programs? One, declaring in the public section, violating encapsulation. When we declare it, the data in public section, no need of member functions because we can access it outside. If the data is in private section, then only we have to make use of member functions. So why we need a member function? I guess you got it. Let me know. We'll go to the next concept. Okay, thank you, Reena. That same example I have explained here once again, just see. But with the introduction of implicit object. So what an implicit object is? So I mentioned in the program, when you use this radius is of which object? This radius is of which object? Here there is no object name, only plain variable is there, radius. How you will come to know that this is of this particular object? What is the criteria for that? So here comes the concept of implicit object. Any member function defined in the public section must be called from the outside world. So when you call from outside world, you have to make use of an object. Without object, you cannot invoke it. So the object which you use to invoke a member function, call a member function, is available to the class implicitly. So when you simply say radius, that radius is, you are in call init. Let's say you are in call init now, c1.init. You have entered the call, you have entered the definition init. So in this definition, you assign x to radius. This radius is of which object? By default, it is of implicit object, the object which has been used to invoke the member function, call the member function. So here init is invoked upon C1. Init is called with C1. So radius is of C1. X is assigned to radius and that radius is of C1. Got it? So radius is implicitly going over there. Now again in the call, find area. In find area again, we entered find area. We have called find area. We will enter the definition find area. Return 3.14 into radius you have said. And this radius is of which object? It is of implicit object. Who is implicit here? Who is used to call the member function? C1 is used. So that's why C1 is implicitly available and that radius is of C1. So you will get a output of this C1. Yes, you are right, Trainer. C1, implicit object. So I hope the idea of implicit object is clear to you. So this radius is available implicitly. Now, something related to the implicit object, we have one concept here, that is this pointer. This is a keyword in C++ and it is a pointer that stores address of an implicit object. It holds address of an object that has been used for invoking the function. To access this object in class, you have to make use of value at address operator because it is a pointer. Whenever you use pointer, you must make use of value at address operator. So someone has asked here, Aditi Raina has asked why we can't make a program public in the previous section, previous topic. We discussed, no, if you make it public, what happens? It is accessible to the outside world. So if it is accessible to the outside world means your data is not secured. Anybody maliciously can damage or corrupt your data. Because it is open, it is available. So if you put it inside a class with private, it is not accessible. He cannot enter in the class unless you allow. So that's why you are not encapsulating. So you should avoid the data using public section. In public section, can we use protected? Yes, you can use protected. Protected is like private itself, but it has some significance to inheritance. Otherwise, it has no any difference between private and protected. They are one and same. Private is not inheritable in the subclass. Protected is inheritable. That we'll discuss in detail in inheritance. Now let's continue with this pointer. So how it is done? That one example we'll see here. Value add this. So this pointer is primarily used to hold or store address of which object? Implicit object. You can see here, I have used this. Can you see the screen now? Look at the program. Here we had earlier used init, only radius we had used. So actually by default this will be there. That's why it is this. By default this implicit object will be there. By default this will be there. So if you want explicitly, if you want to make a reference to the implicit object, then you can make use of value at this pointer. We'll make use of one application, one program we'll use in which this is the use of this pointer is inevitable. You cannot avoid the use. That one example I'll show you. But here right now understand this part is there. By default it is there. Run it and see. So it is 19.625. That is this one. Now I'll remove this. So if I remove, what happens? It is there by default. Even if you don't say by default, it is there. Implicit. So I'll remove. then also the program works because by default it is there. See, this is there. Now run it and see. There is no error because even if you remove, by default it is there. That's why it is this pointer. This pointer holds address of an implicit object. When you say star this value add address this, it will refer to implicit object. We'll make use of this concept in one example later on. It is coming. We'll see. So I think you got an idea. Sir, please explain that implicit concept again. Yeah, it is coming again. Don't worry. It is coming. Sakshi, it is coming. Don't worry. There must be a clear screen while run the program. Yes, it is there. Clear screen I had given because it is a DOS version. No, the clear screen is required. So let's go to the next point. Now, you have seen the implicit object is available. The implicit object is available to the class. The member function find area is computing area of a circle. So it needs area of one circle it is computing. So that one circle object is made available to the member function implicitly. When you say c1.find area, you are passing c1 implicitly. c1 is available to it implicitly, that you have seen now. If the function processes more than one object, if there is need to process more than one object, then how you will pass remaining objects? The remaining objects must be passed as parameters. So one object you will use for invoking, and that is made available to the member function implicitly. Rest of the n-1 objects must be passed as parameters. And these objects we call as explicit objects. Let's take an example of circle again. Now, the task is to create two objects, two circles, and find total area occupied by these two circles using single member function. So why I have put the constraint single member function? Because if you use two calls, like in the previous example, we found area, find area. C1.find area plus C2.find area. This will also give you the total area. But here you are giving two calls. You are making two calls, but I want with a single call. The single member function should give me the total. So your member function is processing two objects now, two circles. Two circle objects. One circle object is going implicitly. The remaining must be passed as a parameter. We'll see that. Example we'll see. This is the example for that. Passing object to member function. If the member function needs more than one object, then how we should pass remaining objects? We know one object we pass always implicitly. When we call a member function with some object, that object is made available implicitly. Okay, no issue. What about the remaining n-1 objects? They must be passed as parameters. Now we are computing total area occupied by two circles, two objects, two circles. So one circle object is used to call a member function that is made available implicitly, and one is passed as a parameter. You can look at the program here. So two objects I have created, circle C1, C2, two objects, two circles created. The radii are initialized here, C1.init 2.5, 1.5. C1.init. When you go to init call, when you go to init call, you are in init call now. Okay. Now you are in init call. If I ask you, this radius is of which object? You are because of which call? You are because of C1.init. So C1 is the implicit object. So radius is of C1. So it completed the call. then it takes C2 dot init. Again, you will enter the definition. Now this radius is of which object? Who has called it? Who has called it? C2 dot init. So C2 has called it. So C2's radius it is. So this is implicitly available, C1, C2. So both have been initialized now. Now C1, C2 have been initialized. Call the find area. C1 dot, you are using C1 dot find area. It will, C1 is passed implicitly. So this radius, when I say radius into radius, this radius is of which object, C1 or C2? This radius is of which object, C1 or C2? Come on, let me know. C1 or C2? Just radius, just that radius is there, no? That is of which object? Come on, quickly type. Quickly type others. Some, most of you are saying it is C2. Most of you are saying it is C2. Some, very few are saying it is C1. So who is right? I don't know. You say C1. Some are saying C1, some are saying C2. So, okay, fine. Now again, I will make it clear once again. See here. You are in which call? You are in find area. You are in find area. Find area. This is the call. Because of this call, you are here. Am I right? Because of this find area, you are here now. Okay. Who has called find area? C1 has called find area. So who is available implicitly to this function? C1 is available implicitly to this function. So this radius, without any object, if any attribute appears, variable appears, that is of implicit. So this radius, there is no object, means whose which object's data it is. It is of implicit object. So who is implicit here? C1 is implicit. So radius is of C1. This radius is of C1. C2 is being passed as a parameter. See, C2. I am passing it as a parameter and I am collecting it in Cx. You are passing C2 in Cx. So C2 is copied in Cx. Now Cx dot radius you have to say, because it is a explicit object. It is passed as a parameter. C2 is an explicit object. So its states are accessed using object. Here there is no object. You say that there is no object here, but by default there is an object. Just now in the previous program you witnessed star this dot radius. What does it mean? Star this is an object, implicit object. Even if we don't say, by default it is there implicitly. That's why we don't mention it. Even if we mention, it works. That you have seen already. So now C2 is being copied in Cx dot radius into Cx dot radius. So this is what the total area. Now you are returning this total area here and you are printing it. So this is how, if a member function needs n objects for processing, if a member function needs n objects for processing, one object you can use for calling, that is made available implicitly, and the remaining will be passed as a parameter. Now I'll change the scenario. I'll make C2. I'll use C2 for calling. No harm. I can do so. The left object is C1. C1 I'll pass as a parameter. I don't need to change the definition, because now this radius is of which object? Implicit object. Who is implicit now? C2 is implicit. And C1 is passed as a parameter. So C1 is explicitly copied in Cx. Now Cx dot radius means, see, if you run, you get the same output here. See, 26.69. So if I change it to C1, same output you will get. See, C1, C2. Run it again now. There is no any change. You will get the same thing. It is same, 26.69. So if the member function needs n objects, one object is passed implicitly, because at the most we can invoke a function with only one object. So one is implicitly, remaining n minus 1 objects are passed explicitly. Now you can see here. This is what explicit and implicit. Let's explore more about implicit and explicit. It's very interesting concept, explicit, implicit. You must understand. If you understand thoroughly, then you will be able to define the classes and define member functions and process the things comfortably, conveniently. Let me know here. Really, is it interesting concept, implicit, explicit? Have you heard of this implicit, explicit before this? Come on, let me know. Type and let me know. Okay, good. Come on. Yes. It's really interesting, no? Okay. So what is implicit? The object used to invoke. And what is explicit? The object which is passed as a parameter. In the calls, if you pass something, it is passed as a parameter. It is treated as a parameter and it is explicit. Okay. Now one more very interesting the program is coming over here. You will enjoy really. Later on again I'll take the feedback whether really you enjoyed or not. Let's go to this example now. So the example here is, let's define a class called account with data as balance. Fine, you are familiar with the class account and there is a balance. Create two objects, create two accounts and swap their balances. Can you think it's easy? Can you guess? Can you guess the solution program? How it will be? Let's see now. Yes, this is the program. Just go through it first. There is a init function used to initialize balance. There is a display function used to display balance. Because balance is private, to initialize I must come to the class. So I'll be taking the help of init. To display it, I must come to the class. So I'm taking the help of member function display. Then there is a swap function. So the call is like this. There are two account objects, account A1, A2. Then you will be initializing them. A1 with 5,000, A1's balance will be 5,000, A2's balance will be 7,000. So I'll be displaying them before swap. What is the output? 5,000, 7,000, and I'll swap them. So the swap function is processing two objects, A1 and A2. Two objects, one is passed implicitly, the other is passed explicitly. So the one which is passed implicitly here is A1, account 1, and the one which is passed as a parameter is account 2, A2. So I done it, I did that swapping, and I'll display after swap A1, A2. You just go through it once again. I'll ask you the output. So you can type the output on screen. Go through the program once again. There is a init function, initialize to initialize is the balance, display, and then swap. The swap is this. You focus on swap and the call. The call is A1.swap A2, and this is the definition. Just take few seconds to go through it. Look at the definition swap. I'll be taking one temporary variable. You know, for swapping we need a temporary, and in temporary I'll copy balance of implicit object, and then ax dot balance is assigned to balance, and ax dot balance again back temporary value stored earlier, and then I come back. Shall I go back to the Windows screen so that I can read your chats? Just give me after swap. Good, very good. Come on, quick, keep typing. From Himang Taggi, 7,000, 5,000. Good, very good. Come on, quickly respond so that I'll come to know whether you are on the same page or no. A1 7,000. Okay, fine. What about A2? Prachi. What about A2? Prachi Desai. Yeah, A2 is 5,000. Okay. Okay. 7,000, 5,000, 7,000, 5,000. Good. Good. 7,000, 5,000. 7,000, 5,000. Good, good. Very good. Good. Sanya. Good. 7,000, 5,000. Good. Very good. Okay. Good. 5,000, 7,000. Good. Quick. We have a lot of programs further. You need to study them also. Quick. I guess many hundreds of people are there online. So all are taking part. So all of you try to chat. Give the reply. Ashish Wagmare, 7,000 you are saying, only one value. Ashish, 5,000, 7,000, 5,000, okay. Quick. Okay. Before, after swap. 7,000, okay, good. Okay, fine. Now, let me kill your curiosity, kill your anxiety. I'll show you the output now. Let me kill your anxiety. Let me show you the output. A very important fact I am revealing with this program. See, now I'll run it. Can you see the screen? Don't be shocked. The output is right. System is right. No one has given this output to me. How come it is 7,000, 7,000? How come it is 7,000, 7,000? Let's start again now. How come it is 7,000, 7,000? Yesterday, I discussed functions. Someone is saying swapping temporary. No. A1 into swap. Actually, yesterday what we did, C++ functions, we can call by value, call by passing address, call by reference, I said. And in the same slide, I had written what is the limitation of call by value. Can you recall the limitation of calling a function by passing value of a variable? What is the limitation of it? The limitation is what? When you pass value of a variable, and if it gets modified over there, it will not reflect unless you use a return statement. You have to make use of a return statement, or you have to pass address of the variable, then it gets modified, or pass by reference. Now look at this program, look at this code. here you are passing A2. You are passing A2. And this A2 will be collected in AX. So A2 is a value of an object that is copied in another local variable AX. AX is local now. A2 is been copied in AX. AX is local to this swap function. Any modification done to the local variable will be local only unless you reflect it back, unless you return it. So you have to return AX, then collect it in A2, then it will reflect. Now AX is local. Here if you print in swap, if you print balance and AX dot balance, it will be 7,000 and 5,000. Here AX dot balance is there, no doubt. AX dot balance is 7,000. Balance is already 7,000. A1's balance is copied in temporary, that is 5,000. AX dot balance 7,000, that you made balance. A1's balance became 7,000 now. AX dot balance temp is 5,000. So AX dot balance here it will be 5,000. So here balance is 7,000. AX dot balance is 5,000. Here they got swapped, but this swapping will remain local to this function. This will remain local because AX is local. AX is local. That's why any modification done to AX will remain local. A2 will remain unmodified. A2 will remain unmodified. The modification will not be reflected back in A2. That's why A1 got modified, because any implicit object, if it gets modified, automatically it will be reflected back. A1 was 5,000, you modified it to 7,000. That A1's 7,000 is reflecting back. But A2's 5,000 is not reflecting because you are not returning. Neither you are passing address nor you are passing it by reference. So A2 will remain unmodified. A2 will remain 7,000. A1 modified 7,000 because it is implicitly passed. Any modification done will automatically reflect back. So A1 became 7,000, but A2 remain unmodified. It is left with its original value 7,000. That's why when you say A1 dot display, the modified value is reflected 7,000. A2 dot display, which is the original value, unmodified, because you have not reflected the modification back. Am I right now? Did you got this point? Let me know so that I can continue. Did you get my point? Why A2 is not modified? We passed it by value. It got collected in AX. AX is local. Any modification done to AX will remain local. And when you come out of it, it is destroyed. So what? A2 remained unmodified. That's why to modify A2, you have to return AX from the function, or else pass address of A2, or else pass A2 by creating alias name. Yesterday I showed you. Now I'll show you both ways. By passing address and by passing reference and returning. All three methods we'll see. So now we realized that in order to reflect the modified value, local variables modified value, local objects modified value, if we want to reflect, we have to make use of return statement, or we must pass the address of the variable, or we must collect the variable by reference using alias name. These three ways are there in C++. Now let us see that thing. Let us first see with return statement. So your AX is modified here. AX is actually modified, account AX. You are returning AX, return AX. So this is a returning object now. Your member function is returning something. Since earlier it was void because there was no return statement. Now you have a return statement, you are returning something. What are you returning? You are returning AX. What is the type of AX? The type of AX is account. The type of AX is account. So the return type is now account. Account is a return type. Since you are returning, you must collect. AX represents which object now? AX is representing A2 now. So I want to copy it in A2. A2 is equal to. Now AX is copied in A2. That modification is reflected in A2 now through return statement. This way you can reflect the value back. Let's run and see now the output. See now, after swap 7,000, 5,000. So they are getting swapped. Got it now? This concept of returning. Okay, I don't want this returning. I want to keep the call simpler. So I don't want return statement here. I'll make use of let the return type of swap be void. And still you want to reflect the AX back to main. Yeah, it is possible. Send the address of A2. Send address of A2. Any modification done to it will automatically reflect. Since you are passing address, you must collect it in a pointer. Now, star. AX is not object now. AX is address of object. So since AX is address, dot will not be used with this one, arrow will be there. You have seen in C also, when you use address to access a variable from structure, you will use arrow. AX arrow balance, AX arrow balance. Now, this is how, when you use pointers, the readability will be degraded, little bit complicated. See, now also it is running perfectly after swap. So I don't want this pointer. I feel that pointer is a dirty concept. I don't like it. So I want to use one of the very easy concept of C, that is reference variable. So I'll create only a reference variable. So AX is alias name for A2 now. AX is alias name for A2. So remove this address operator from here. So AX is alias name for A2. Any modification done to AX will automatically reflect back in the calling function. See now. So you're getting, say, output 7,000, 5,000 there. Did you really enjoy this concept? Tell me now. Did you really enjoy the swapping? 3 ways are there to reflect the value. One is to use return statement, use address, use pointer, and use a reference variable. This way there are that. So any doubt if you can ask me. We'll proceed otherwise. We'll go ahead. Good, good. Thank you, Siddhi. Thank you. Good, good. Okay, very good. Most of you are not having any doubt. You are clear with the concept. Good, very good. Good, very good. Thank you. Thank you, Himang, Taggy. Thank you. Int, for what you want to use int, Chinmay? Okay. Okay, good, good. Let's go now. Continue with the session. Most of you got the idea. If you have any doubt, later on the slides are available to you. You refer it, go through it. Some assignments are there for you. Just copy down these assignments and try afterwards. Okay, we'll continue. You got it? These examples, you try later on. The next concept is returning an object from class. You have seen now. We returned one object, temporary. There's a swapping AX object we returned, and we collected. Now the same thing, same idea is applied here. Let's take an example of time class, which has data members as hours, minutes, and seconds. Create two time objects and add them to store it as another time object. How will you do it? So define a class time with data as, look at this. So this is a simple class with data members, hours, minutes, and seconds. Then we have initialize function, init stuff will be there, we have initialized. Then display hours. The main function is add function here. We are adding two time objects and storing the result again as a time object. Because when you add two time objects, the result is again the time itself, hours, minutes, and seconds. So the resultant object is time object. So this is important for us. Let us see now this one. So here when you define a function for returning something, you must take utmost care to specify the return type correctly. You are returning you are returning the resultant object. The resultant object is again of time. That's why the return type is time here. So what is this temporary variable doing? It is temporary holding the result. In one temporary object, we hold the result and then that will be returned. The remaining stuff is conversion stuff. You can make out that if minutes are more than 60, you should convert it to hours. And if the seconds are more than 60, you should convert them to minutes. And the remaining should be shown as a seconds. This is how we have done the conversion. And this is a returning object concept. So we can run it and see this example. The time example we'll see. Run it and check. So same thing here, class time. There are three data members, hours, minutes, and seconds. Init is there. Init is used for initialization. You will read the values of hours, minutes, and seconds for here. Then display it in hours, minutes, seconds format. And this is the function, add function, time add. You will take one temporary variable, add hours, minutes, and seconds. If seconds exceed 60, convert them to minutes, increment minute, and remaining you show it as seconds. Mod 60 means what? It deducts minus 60, and whatever is left, that will be put as seconds. If somebody gives seconds as 130 seconds, if you read 130 seconds, that time 130 seconds has 2 minutes. So what you will do? It will only increment by 1 only. So you have to take care here. You have to modify this. If that is the case, you have to change the logic. But what I have assumed now here, you will enter seconds less than 60 or equal to 60, minutes less than 60 or equal to 60. With this assumption, this logic is there. If you give the freedom to user, enter any value, he is entering 90 minutes. 90 minutes he is entering. Then because 90 minutes already has 1 minute, 90 plus 50, 140. 140 is greater than or equal to 60, true. So it will increment by only 1. It should be incremented by 2. That thing you have to take care here. So the assumption used over here is the input will be less than or equal to 60 minutes or seconds. If it is more, then you have to change the logic. Let me run it and show you. Hours, say 2 hours, minutes, 40 minutes, seconds, 30. This is the first time object. The second time object, hours, 1 hour, 30 minutes, I'll say, and 40 or 50 seconds. So what is the time now? 40 minutes, 30 plus 80 seconds. 80 seconds minus 60 means 30 seconds. 1 minute is incremented. Here already 30 minutes, 71 minutes. 71 minutes, 60, yeah, that will be incremented in hour. So left with how much? 11 minutes. 11 minutes, 30 seconds, 4 hours. So 4 hours, 11 minutes, 20 seconds. So 30 plus 50 is 80 seconds. 80 second, in 80 second, 60 second is being taken in minute. So left with 20 seconds. 40 plus 30, 70 minutes. 70 minutes, 60 minutes is being taken in hours. So left with 10. But already 1 minute from the second we have taken 11 minutes. So it is a correctly giving. So this is how the returning object will be there. For this kind of examples, you have to make use of returning temporary object, and the return type must be specified correctly. I guess you got the idea. Let's go to the next concept. Let's try another example of returning object. Say there are 2 account objects and you are supposed to return an object corresponding to max balance. So read the problem statement once again from your side. There are 2 account objects and you are comparing their balances, and you are returning an object corresponding to max balance. Your method, your function should return the object which corresponds to max balance. So there are 2 objects, A1, A2. If A1 has balance larger than A2, A1 must be returned. If A2 has larger than A1, A2 should be returned. So what is the logic? If else logic, so simple. Let us see now this one. So this is the program for it. Go through it. So I want you to write here account, what to return, return. If Ax dot balance is greater than balance, return what should be returned, else what should be returned. So note it once again. Look at the call also. Call is like this: Amax is equal to A1 dot Amax A2. A1 is passed implicitly, A2 is passed explicitly. So that these two are compared over here. And then what is that? So Siddhi has told return Ax, else return A1. Okay, fine. Others, come on. Anybody with only one person has typed the reply? Come on. Reply what it should be. Return. First return what it should be. Return Ax, return A1. Okay, fine. Omkar Wagmare. Omkar Wagmare. Return Ax, return A1. Okay. Others, be interactive, guys. Don't sleep. Return Ax, else return A1. Chinmay. Okay, fine. Else return A1. Okay. Okay. Else return A1, return Ax. So the first return is correct. Return Ax. When you are saying return A1, A1 is not there in that scope. A1 is in mains scope. A1 is there in mains scope. Are you getting my point? A1 is return bal. You are returning bal. Someone is saying return bal. Bal is a primitive. Bal type is double. What is the type of bal? Double. Are you getting my point? So what is the type of bal? Double. But your return type is account. How can you return bal? You are collecting it in Amax. Amax is an object. Bal is a primitive. Mismatch will be there. So bal is not right. A1 is also not right because A1 is in the scope of main. It is not in the scope of class, or it is not in the scope of find max. Come on. Come on. Anybody? Chat quickly. Yes, very good, very good. Ashwini Suhase, you are right. You are right. Very good. Others? Come on. Very few are there online. So hardly 3-4 guys are chatting. Rest of you are not taking part in the discussion. Siddhi, you are also right. Good, very good. Come on. Good, very good. So just a few minutes back, we had discussed one concept. Yes, this pointer. So we are supposed to refer implicit object, no, here. We are supposed to refer an implicit object. What is that implicit object? Star this. We are supposed to return balance. Balance corresponds to which object? If ax dot balance is greater than balance, it is for sure object ax we are supposed to return. We are returning object ax. Okay, fine, no issue. Correct. Else balance is greater. Balance is greater means which object is greater? A1. A1 is not accessible here, but here A1 is accessible as implicit object. So that implicit object is available in this pointer. So you have to say star this. Then it will reflect that thing. So now here, let's run it and see. 2 7,000. It is A2. Now I'll make A1 bigger. 15,000 I made. Now it should be A1. See, 111, 15,000 is the salary. So this is how you have to make use of here. Here star use of this is unavoidable. You have to make use of this because without this, there is no way out to return the implicit object. So whenever you are supposed to refer an implicit object in member function, you have to make use of this pointer. This is the advantage, or this is the use of this pointer. I hope you got the idea. Did you like the example? Okay, good. Okay, fine. Now let's continue. Okay, good. Thank you, Omkar. Thank you, Omkar. The next concept is constructors and destructors. Just look at the slide and look at the image also. What they are doing, just tell me. Yes, right. They are constructing. Yes, you are right. Constructing the structure using sand. Very good. Building. Father is building home with sand. Yes, correct. Very good. Good guess. Right, you are right. So now the same thing we have here now. We are supposed to construct an object. Since object is user defined, you are defining it. The user is defining it. The system is not knowing that object. Very good. Construction. You are all right. Good. Very good. So object is user defined variable. The system is not knowing how to construct it, how the memory allocation should be done, how it should be initialized, what should be the default initial value. These things are not known to the system because it is your variable. So you must construct it. You must allocate memory for it. You must initialize it. For this purpose, C++ makes use of the concept called constructors. They are used to construct an object. They help to build memory for the object, allocate memory for the object, and thereby initialize or set some initial values for that object as per the attributes, as per the states. This task of allocating required amount of memory for an object and setting up its initial values is done by this special method or member function. And this is called as constructor. It is special because it has the function name as class name itself. So what are its characteristics? We'll see in the next slide. See what are the characteristics. It has the function name same as class name, and it has no return type, not even as void. And it is called automatically. You don't need to call, like you used to call init a1.init, c1.init. Here there is no need. When you say account a1, automatically the constructor of that class account is called. When you say circle c1, the constructor defined for that will be automatically called. And usually it is defined in the public scope, and it cannot be used as virtual for polymorphism. It is the last characteristic right now you cannot understand. We'll once again discuss it in inheritance and polymorphism. Time being, you ignore it. The first 4 points you remember. Okay, got it? We'll see one example of it. Before the example, let us see types of constructors: default constructor, parameterized constructor, and copy constructor. Someone is asking, if we use the constructor in the private section, what happens? If you use it in private section, you know anything defined in private can be only accessed in the class itself. It cannot be accessed from outside world. So you will not be able to create objects. Means you will not be able to make use of the constructor outside the class. Only you can make use of it inside the class. Whenever you create objects inside the class, that constructor will be called automatically. If you define it in private section, and when you create objects outside the class, that constructor is of no use because it is not accessible. That's why normally it is not defined in the private. It is defined in private when only objects are created inside the class. If the objects are local to that class itself, that time you can make use of private section for constructor. And why can't we use constructors there? Where does that mean that only variables are declared inside private section? No, even the member function, some member functions we can declare inside private section, and those member functions are only called by the class. They cannot be called outside the class. This is the difference. Okay, we'll see in detail now. Okay, thank you, welcome. The different types of constructors we'll see. Just give me 1 minute. I'm getting some message. I'll check. Okay, now I'm getting a message from the technical coordinator that we have a session, another session from 4 o'clock. We'll not be able to extend the session today. Actually, we started late and I intended to extend it by half an hour and complete today's part. Because of this time constraint, we'll not be able to do that. So the remaining part, like the types of constructors in detail and example related to it. This is a program to demonstrate constructors. This part we'll discuss tomorrow. So now we have one simple quiz here. This part is also left now, static and non-static. This also quickly we'll cover tomorrow in the beginning. Today we'll wind up at 4. So before we wind up, we'll take a simple quiz for you. If you are familiar with previous knowledge of static, non-static, you will be able to answer. We'll see. The object used to call a function is called what? Quickly type the thing here on message window. The object used to call a function is called, quickly type. Very good, very good. Come on, others. Siddhi, you are right. Yes, you are right. Good, good. Yes, right. Many of you are, no, not call by function. It is implicit object. Call by function is not there. It is implicit object. See here. So it is implicit. The address of implicit object is stored in what? Quickly type. Yes, very good. Very good. Quickly. Yes, very good. It is this pointer. Don't say star this. Star this means it is a implicit object. If you say address means only this pointer. Yes, you are right. So this pointer. T must be small because it is a keyword. The special member function used to allocate memory and initialize is what? What is that member function? Quickly. Yes, right. Very good. It is constructor. The return type of constructor is quickly. The return type of constructor is, what is the return type of constructor? Yes, right. Yes, very good. Very good. I'm happy that you got the characteristic. Yes, very good. It has no return type. Good. Very good. It has no return type. Default destructor is called when object. We did not discuss today, no, destructor. Destructor is again a special method, member function, which is called when an object goes out of scope. Very good. Object goes out of scope. Very good. When object goes out of scope. The property or behavior common to the class is described using static. The property specific to an object, this we are supposed to discuss tomorrow. We'll do it. The property which is specific to object is non-static. To access states of an implicit object inside class, object name is not required. True or false? Quickly, number 8. Answer number 8. This we have discussed thoroughly. True or false? Quickly type. To access states of an implicit object inside class, object name is not required. True or false? Yes, right. Most of you are saying it is true. But I say it is false because object name is compulsory. It is there. Star this is there implicitly. Implicitly it is available. So by default it is there. We don't need explicitly. So false and true both are right. If you are saying true, then also it is correct because we assume that it is implicitly available, so there is no object. But those who are saying it is false, they are thinking that there is an object. There is object implicit star this, but it is by default it is there. That's why we don't need. Come on, very good. Ninth question. Ninth is member function defined inside a class are by default. What kind of functions they are? Member functions defined inside class are by default inline functions. And to make a member function non-inline, it must be defined inside class. True or false? Quickly. To make a member function non-inline, it must be defined inside a class. Yes, it is false. It must be defined outside, not inside. When we define a member function outside using scope resolution operator, it will become non-inline. Otherwise, if we define inside, it will become by default inline. Okay, fine. So we'll wind up the session here. The left part, today's left part, we'll cover tomorrow quickly in the beginning, and hopefully we'll start the session in time. And I hope you enjoyed today's session. It was quite program oriented. A lot of programs were there. A lot of concepts were there. So I would like to know how overall rating of the today's session. Out of 5 rate today's session quickly. On message box, quickly rate today's session out of 5. Very good. Thank you. Most of you are saying 5. Oh my God. Thank you so much. Thank you. It means really you enjoyed. Very good. Thanks a lot. Thank you. It's a motivation for me. Thank you so much. Thank you. Okay. With this, I'll wind up the session. Take care. Be at home and be safe. Bye. We'll see you tomorrow. Thank you. Amit sir, I'll hand over to you. Prashant sir, I'll hand over to you for attendance purpose.
Yes, sir.
Thank you.
Yes, sir.
Most of you are saying bye. Oh my God. Thank you so much. Thank you. It means really you enjoyed. Very good. Very good. Thanks a lot.
Okay, sir. Thank you. See you tomorrow, sir.
It's a motivation. Okay. Thank you. Okay. See you tomorrow.
Yes, sir.
Okay. With this, I'll wind up the session.
Yes, sir. Yeah, we'll end up the session, sir.
Yes, sir. Most of you are saying bye.